Smartphones, TVs, computers, iPads, and many other modern miracles are made possible by power-efficient LED screens, but the real impact goes well beyond our brightly lit gadgets. Lighting accounts for 20 to 30% of global electricity consumption and about 6% of greenhouse gas emissions. Given that LED bulbs use around 80% less energy and last 25 times longer than incandescent lighting, they have the greatest potential impact on energy savings globally. But when the first LEDs were introduced in the 1960s, they didn't have much use. It wasn't until the 90s when Japanese scientists discovered the missing link needed to complete the colour spectrum: the blue LED. Here's how the colour blue changed lighting. After Thomas Edison invented the light bulb in 1879, incandescent lights lit much of the 20th century. The problem is they waste a lot of energy, lost in the form of heat, and they don't last long. Fluorescent lights started being used in the 1930s. Although much more efficient than incandescent, they're not an ideal replacement. They contain toxic mercury, age significantly if they're frequently switched on and off, and are prone to flicker. There needed to be a better solution. In 1961, Gary Pittman and James R. Beard of Texas Instruments accidentally invented the first practical light-emitting diode while trying to make a laser diode. The first LEDs emitted infrared light, invisible to the human eye, which later became useful in things like remote controls. And for the next 3 decades, advances were made to include red and green, but they couldn't quite get to blue, which was needed to make white light. But the appeal was obvious. Unlike ordinary incandescent bulbs, LEDs don't have a filament that will burn out. They don't get hot, and they require a lot less energy. So the biggest electronics companies raced to create a powerful blue LED. But the problem of the missing colour plagued them for nearly 30 years. A key ingredient, a chemical compound called gallium nitride, proved difficult to grow in a lab. Scientists tried and failed, ultimately turning their attention to other more promising semiconductor materials for creating blue light. But a number of favourable circumstances led a scientist from a small chemical company in Japan called Nichia to finally make the discovery. Firstly, by virtue of having little to no budget, scientist Shuji Nakamura was forced to create red and infrared LEDs from scratch, using parts he scavenged and fixed by hand. Most companies in the 80s were creating LED material using commercially available equipment. This experience, which took him around 10 years and featured monthly explosions in the lab, would later prove invaluable when doing trials for blue LEDs. The second reason was his decision to use gallium nitride, a material considered a dead end by other scientists. But his motivation for using the chemical compound was personal: getting his PhD. According to Nakamura, writing papers on less promising candidates for blue light would make it much easier for him to get the necessary papers published for his degree. Again, he went back to the lab, not taking holidays and not varying his daily routine. But this time was different. He convinced Nichia to buy the equipment for manufacturing LED material. Instead of starting from scratch, he made small modifications to the commercially available equipment. His extensive experience building red and infrared LEDs aided the alterations. Just over a year later, Nakamura made his first successful growth of gallium nitride. His method, called the two-flow MOCVD, is still used to this day. From this and discoveries of other Japanese scientists around that time, he was able to produce the first brightly shining blue LED. Nichia is still a leader in the LED industry, used by Apple and other electronics manufacturers. In 2014, Shuji Nakamura was awarded the Nobel Prize in Physics for his invention, along with 2 other Japanese scientists who developed high-quality gallium nitride materials prior to Nakamura's breakthrough. The small, energy-efficient and extremely bright LEDs started a light revolution and are now used in almost every piece of electronics. Without it, much of what we use today wouldn't be possible. It also has life-changing implications in the developing world. With LEDs, solar panels and small batteries are more than enough to power the homes of the 1.2 billion people who lack access to electricity. Most of those people are still burning wood or gas for light, which is not only inefficient, it causes pollution. It's estimated that switching all lighting to LED would reduce annual carbon dioxide emissions by about the same amount as that produced by 3/4 of the cars in the US. That's a potentially bigger impact than wind or solar power. And with global warming due to human activity generating catastrophic effects on the planet, the desire for saving energy is bigger than ever.